The endoscopy industry has a clear vision of where it's heading. Firstly, higher resolutions and wider view imaging to enable more accurate decision-making and use of AI. And secondly, the transition to single-use endoscopes to avoid contamination risks and costly sterilization procedures. In an attempt to achieve both goals, the industry has faced a technological roadblock, finding a high-resolution, long-reach connectivity solution that can withstand electrosurgical interferences without being affected and dropping the image, which can put patients at risk. To add to the signal integrity challenge, for the solution to be viable for endoscopes, a small form factor and power consumption is required. And on top of that, to be relevant for a single-use endoscope, it must be a cost-sensitive solution. Valence is excited to introduce to the market a new connectivity solution that ticks all these checkboxes. The first and only solution with a built-in electrosurgical noise canceller, allowing for reliable, high-bandwidth connectivity for next-generation endoscopes. All in an extremely small form factor that can fit in small distal-chip endoscopes. We have assembled a simulation that puts the #1 challenge to the test, maintaining the video image during a procedure involving cautery. The setup includes an endoscope through which we run the Valence VA7000 SerDes connectivity solution alongside an electrosurgical probe for cauterization. At the tip of the scope, we have a 4K CMOS sensor running at the highest frame rate. The sensor data is driven from the tip of the scope using the Valence VA7031 serializer over a very thin and flexible 5-meter coax cable. On the receiving end, the Valence VA7044 deserializer is connected to the NVIDIA Orin processor that displays the 4K video. Solutions on the market today using only forward error correction or no correction methods at all cannot handle the electrosurgical procedure interference. We simulate this by running the setup with the VA7000 noise canceller disabled. Turning on the noise generator to a level of just 10 watts and using the probe on a lemon simulating a patient, the link fails and the video freezes. Now let's repeat the process, but this time turning on the Valence VA7000's built-in electrosurgical noise canceller. As you can see, the video remains picture perfect at the same level of 10 watts. We can do it again, turning the noise higher, and again, the video remains uninterrupted. So I said the Valence VA7000 SerDes ticks all the checkboxes, and we just covered 3 of them: resolution, distance, and immunity to electrosurgical interference. Another important consideration is the overall system cost. The VA7000 supports convergence of power and controls over the same cable as the video. This enables powering and controlling an LED light at the tip of the scope. On top of that, the VA7044 deserializer has an internal pulse width modulation generator that supports the LED and the sensor with no need for costly external circuitry that typically includes an FPGA or CPLD component. Demonstrated in this setup is the ability to adjust the LED brightness going all the way up to 10 watts. Additional VA7000 SerDes solution key features include an ultra-low power consumption of less than 230 milliwatts on the serializer end and a compact, flexible solution that can operate even over unshielded cables and within the tightest of spaces.
The VA7000 series by Valence, the first chip designed to solve the challenges of next-generation endoscopes, helping the medical industry to finally achieve safer, smarter endoscopies.